It is by Pierre Cholet. Welcome, Pierre, on this stage, on the data security and cloud stage. You're the head of business development at Decentriq, a Switzerland-based startup, technology startup, and you will be talking about sharing without sharing. So the case for data clean rooms powered by confidential computing. This sounds pretty interesting. Please feel free to take the floor and present your considerations. If there's time at the end, we'll be happy to have a short Q&A with you. We just cannot.
I'm muted. Thank you, David. I was about to say that's an easy segue with the previous presentation, talking about marketing and the privacy technologies out there. So Decentriq is one of the providers that solve this problem, not only in marketing, in other industries. So yeah, happy to be with all of you. So I'm Pierre. I work for Decentriq. I'm actually located in our Berlin office. That's where I'm based. And yeah, today, before going into the presentation, I think at a high level, what I want to explain is first making a diagnostics of the privacy challenges whenever you have two organizations who want to collaborate on sensitive data, and then explaining the new paradigm that data clean rooms offers, especially the ones powered by confidential computing. And back to the title, sharing without sharing. So we are now in a world where two companies or more can collaborate on data without actually having to share that data to each other. So I will explain how that works. Let me illustrate this with some slides to make it more digestible. So before going into the solution and the problem, I mean, the topic of data collaboration is everywhere. I think from the European Commission to the private sector, especially in healthcare, this is a very hot topic, but marketing as well. We talked about it in the previous conversation, previous talk. So everyone advocates about it, but in practice, there is actually little happening in terms of data collaboration. And the reason is it's actually very hard, honestly, to make this happen if you want to guarantee the privacy and the security of the data at the same time. So I will try to take an example together and really decompose all the privacy issues that arise whenever you have two companies who wants to collaborate. So I'll take an example of in healthcare. So take a hospital who wants to collaborate with a health insurer. They each have patient data. This can be very valuable for them to combine this data for research studies, for value-based healthcare. So hospitals know a lot about the patient, medical records. The health insurer knows a lot about the history of that patient, the cost of the interventions. So combining this data can actually unlock a lot of new insights. So let's take this example and go through now all the challenges that they will go through when collaborating together. And you see here, we are taking a very conceptual, abstract consideration for the computing environment. I'm not pinpointing any particular technology, just one place where the calculation will happen for the collaboration. So when those two companies want to collaborate, first arise the issue of preserving, let's say from the perspective of the hospital, the privacy of that patient data that they want to contribute in the collaboration. So I would call it the input privacy. This is the data provided by the hospital. And here, the challenge is threefold. So first, the hospital doesn't want the collaborating party to actually be able to inspect and see line by line this very sensitive data that they contribute. So collaborating party shouldn't be seeing and accessing this data, this sensitive data. Second, what about the software vendor, the company that offers the software to run the calculation? Yet again, as a hospital, you don't want the software provider to be able to access this data. There's no reason why they shouldn't. And lastly, you also don't want the infrastructure provider where this software is installed to even be able to access and see this data. So you have all those three parties that should be excluded from accessing this information. So that's the first challenge. How can I make sure that my data, my input data, cannot be seen by anyone, all the parties in the collaboration? First. Second challenge, the collaboration happens. Let's say we can combine this data and run some statistics on top of it. How do you make sure that the collaborating party, in this case, the insurer, cannot extract from the results any sensitive information about your patient? So here we are flipping the coin, and I would call this output privacy. You want to make sure that whatever results from the collaboration does not leak anything sensitive about your patient. And here the main challenge is to prevent the collaborating party to learn too much and re-identify your patient data. And it's not over. There's one last challenge that you face. The last challenge is around control. So as a hospital, you decide to collaborate with a health insurer, but only for a specific purpose. This is important. You only want to collaborate for this study, but nothing else. Now, the issue that arises is, how do you guarantee that this other party will not use the data for something else? Like in the case of a health insurer, you don't want them to use this data to potentially increase their pricing algorithm. That's not the purpose. You agree to collaborate to advance research, not to change their pricing approach. So you don't want them to change the rules of the game. And you also don't want the software vendor in the middle to potentially also manipulate the collaboration and change it in a way you didn't want to. So overall, you have really three main issues that all relate to privacy. First, keeping the input, your raw data private, making sure that the results are also private, and finally, guaranteeing that the collaboration is under your control and rules do not change unless you approve them. So that's to paint the picture and the challenge. And I think that's the most important. Once you understand all this, I think the rest will be fairly tractable. So that's all those reasons are the reasons why we at Decentriq built the data clean room platform. And if we go back to this example, the idea is with the data clean room, you solve all three problems. So first, input privacy. No one can ever see the data from the hospital, and same for the health insurer. The collaborating party cannot see each other's data. The software vendor cannot see the data, and even the infrastructure provider, whether it's a public cloud or not. Output privacy, guaranteed as well, that nothing in the results can be used to re-identify the patient. And in this case, there are different techniques. I can go on and explain how they work, but typically you have from simple techniques that force the aggregation all the way to techniques that inject noise, something called differential privacy, into the results. And finally, control. With a data clean room, you actually cryptographically enforce that the data is only used for that particular processing and nothing else. And to get this, we use a technology called confidential computing. I will explain in a minute how that works. It's a hardware technology that keeps data encrypted at all time, and that has certain additional guarantees around the control of the processing. Super quick about Decentriq, so you have some context about us. So as David said in the introduction, so we are a Swiss company with an office in Berlin. We are a founding member of the Confidential Computing Consortium. We offer a data clean room platform, and we operate in the most regulated industries. So typically in healthcare, in media. So I'll give two examples today, but also in financial services and in the public sector with the Swiss Army. Now, if we take a bit of a step back, the concept of a clean room is generalizable not only to two parties, as we saw in the example with a hospital and a health insurer. It works with multiple organizations who want to collaborate. And the way it works at a high level, data never actually leaves those organizations, only an encrypted version, chunk of it, gets ingested into this confidential computing environment where no one will ever be able to access or leak the data. And then results are returned back to the participants that are guaranteed compliant in the given purpose for the given collaboration. A word about confidential computing. I know it's a privacy conference. I don't want to go too much into cryptography and the tech, but at a high level, what is confidential computing and why we are using it to build our data clean room infrastructure? It's a new tech that basically kind of like close the loop when it comes to protecting data. So data, we like to say, can live in three different states, like water. That's often the metaphor. Data is like water, so data is at rest. It's protected with traditional security measures, cryptographic measures, and that's like ice. Data can be in transit, moving from A to B. And typically when you go on a website, you see the log, HTTPS. That means that you have a secure channel between you and the website. Your data cannot be seen. Or if any of you use WhatsApp, that's the same. The concept of my message cannot be read by someone in the middle. Only the receiver can see it. But then the issue until very recently came when you actually had to use this data to run some processing. So you need to run an average all the way to running some machine learning models. The data can be vulnerable, can be accessed by others. And that's what confidential computing solves. It protects the data once, even when it is in use, making such that the data is always protected from rest, transit to in use. So that's the fundamental concept of confidential computing. There is more I could add, but I'm happy to take questions after I'm done with the presentation. Well, super quick about the clean room concept. Again, it's a privacy by design technology. It allows compliance to various regulation. I will give a concrete example. I don't like to throw out there, it's GDPR compliant. I think you heard many others claiming this. It's a technology that helps you being compliant for a certain purpose, and I will show some examples typically in healthcare and in marketing where we've been approved for the use of this technology for patient data, but also on banking data. And because it's based on hardware, it's actually very flexible, and it scales to large data sets, to large workloads, so you can do very simple studies using SQL, all the way to running machine learning algorithm using Python. Now, I will give two very concrete examples, and I think we can then open for questions. I hope it's not going to be, I won't be the only one speaking today. Two examples. One, to start with, in healthcare. Here, this is a project that involves three participants: a hospital, a pharmacy chain, and a pharmaceutical company. What is the goal and the challenge? The goal is how can we assess the adherence to patient to certain drugs and understand why patients after certain interventions stop taking the treatment, others stick to it. To answer this question, you actually need to combine data from a hospital and data from pharmacies, because you need to reconstruct the full patient journey. Issue is, this data set is extremely sensitive. You don't want any third party to be trusted with this very sensitive data. So you need to find a secure way to first combine this data, keep it protected, guarantee that no one can ever see this because you will learn too much about the patient, and guarantee that only anonymous aggregated insights can be extracted from this patient journey. So that's exactly what the clean room here supported. It enables encrypted copy of that data to be pushed into the data clean room. And then this data can be joined, aggregated. This joint data can never be seen by anybody, not even Decentriq, none of the participants you see on that slide. And only aggregated insights are returned to the pharmaceutical company. And this purpose is enforced by the clean room. Nothing else can be done with this data. And it's worth mentioning that's on that slide that we actually got legal approval from the Data Protection Agency of Belgium to perform this study. So when I said earlier it's compliant, it's not just as a void statement, blanket statement, but for this purpose, this study, this was deemed compliant. Now, second example, in marketing, and I think that will tie back the talk we had just before. Cookies are going away. That's a given. We now are living in a world where you don't want your personal information to be shared across many organizations, but as a brand, you still need to do marketing. So you still need to be sure you are reaching the right audience. What does it mean? It means that in the new world we are living in, you actually need to rely on your first-party data, so your customer data, to reach the right audience. Now, of course, the problem of privacy arises. As a brand, how can I use my first-party data, but I want to guarantee that this data remains private? I don't want this customer data cannot be accessed by other parties. It's a breach of contract I have with them. So how can I use it? Well, that's yet again a very typical example. So here, let's take an example that is live in production with a bank. So a brand that is aiming at running a marketing campaign together with a news publisher. So you have on one side a bank that has customer data, on the other side a news publisher that has user data that subscribe to the website and they collect information about the articles you read and your interest. The clean room is the way for those two data to be combined. Again, this remains opaque. No one can ever see it. And outside the clean room, what comes out is first understanding your overlap of audience. Am I, as a bank, about to run a campaign with this company and I want to be sure that it's enough reach? And understand also the profile of our joint users. So you can refine the audience, guaranteeing this is anonymous, but much more precise than you would if you were to simply tell the news publisher to run a campaign on certain age brackets and gender. This is a much more targeted way, but privacy-friendly way of using your first-party data. And from a legal perspective, because I think there's a lot of you in the audience who have a legal and compliance background, you do not need specific consent to use this technology. This is a big breakthrough. You need the consent to collect the data, but you don't need to request a new additional consent to use this technology. So, when you go on a website, you typically in the consent list have to approve all the different marketing technology that are about to collect information about you before the news publisher can use this technology. With this technology, with confidential computing, this is no longer needed because actually no one ever sees the customer data, not the news publisher, not the bank, not Decentriq, and the output is fully anonymous. So there is no sharing of user data that enables, that is much smoother for rolling out this technology. And I think I'm over. Yes, I think we have 10 minutes and I'm done with the presentation. I could speak more, but I think it's better if I open the floor for questions. Please grill me.
Yeah, thank you so much. All right, please, at the audience, exactly, feel free to put your questions. If you want to grill Pierre, please feel free to do so. There you go, Yin, please feel free to ask your question. You might be on the recording then, though, if you don't mind.
That's fine. Thank you, though, for mentioning it. Very privacy friendly. Pierre, this is super interesting and super cool. What I'm wondering now, because I immediately think about the technological issues and the technological questions, is what you described to us as confidential computing. Is that technologically secure multi-party computation, or what is the technological basis for how you set this up?
Very good question. I didn't go into the details. So we use what is called trusted execution environment, which are new hardware. So this is not SMPC or secure multi-party computation, which is a software approach based on cryptography and mathematics. We use the hardware approach. So based on new processor, which basically have a isolated environment of the CPU that guarantees that no one can access the data, and the data is encrypted into the RAM of the processor. So that's the technology we use.
Interesting. Thank you. Cool.
No, my pleasure.
All right. Thank you for this already. Again, feel free to put your questions in the chat. At the same time, I would also have a few questions to ask. One of them is, well, I think, Pierre, the benefits seem clear, and you already mentioned you need a trusted execution environment to execute, but then also kind of calculating on this encrypted data. And so on. How complicated is it to deploy this? It seems like a lot to change in my current IT kind of infrastructure, in my kind of data pipeline. What is it like? How much? Of course, it depends, but like how big of a project would it be?
So from a participant perspective, we actually make this very easy. So what needs to be done in concrete terms is, as a participant, I need to install on my premise a little piece of software that will simply encrypt the data, but that's very lightweight, I would say. So there is a very light encryption mechanism happening on the participant side. And then we take care of making sure that the computation happens inside this confidential computer environment. So those are very low-level environments that you can't interact very easily, but that's what Decentriq has built the past 3 years, making it very easy. So as a user, I can write my very simple SQL statement or language I know, or even click buttons, and this will translate this to the confidential computer environment.
It does sound very intuitive. I will ask another question now, which stems a bit from discussions we have at Bitkom about when is data anonymized, when isn't it? And there's no guidelines, there's not enough guidelines, there's not enough legal certainty. This is something I hear quite often. How do you deal with this problem? It probably also is something you have to tackle. And then, because I assume it often depends on the individual case, how easy is it to scale kind of what you're doing there?
Yes, and that's a question we get all the time, because I think anonymization has been the standard for decades when collaborating. And here we are actually really changing the paradigm. Anonymization is still in place, but anonymization occurs at the end, or what I would call at the output. So guaranteeing that whatever leaves is anonymous. But what this technology enables is using data inside a clean room that is not anonymous and that still has lots of utility. So for the first example, or the two examples I gave, this could not work if you were to use anonymization, because you would lose the capability to link data from two parties. You couldn't do this. With confidential computing, you can still do the linkage. So anonymization doesn't happen at the input, only at the output. When the results come out, then you make sure that it's all anonymous. But you can use very granular sensitive data and link them together before applying anonymization. So you reverse the process, but still guaranteeing the privacy of the data end-to-end.
Interesting, very interesting. Okay, I see. I think there's maybe time for one more question. Again, feel free to in the audience to put your question in the chat if you have any. We'd be happy to help them. it's something we also talk quite a bit about, and because what you do is providing a data clean room solution. I think this term kind of comes a bit also like it also takes place as a data room in kind of due diligence kind of settings between, for example, when there is a merger, these kind of things. At the same time, there's this huge discussion around data spaces on policy and industry sides. Is this a data space, or is this something? Is like how does it fit against this kind of backdrop of data spaces that are kind of being rolled out everywhere? Does it have anything to do with this?
It does. I mean, if you ask me, this is a data space. At least this is a possible implementation of data space. Clearly, we are already powering cross-industry collaboration, so not just in healthcare and in media. We are enabling companies from different backgrounds to collaborate together. So it is, from our perspective, a data space. I think the term data space is also very politically loaded. There's a lot of conversation and different, I would say, appreciation of what it is and what it should be or should not be. But yeah, at Decentriq, we don't do politics. We offer a technology which, from our perspective, can definitely be the solution for these data spaces. But I let the appreciation of the attendees to have their own opinion here.
Interesting. Yes, I think what I can say is that there's no agreed upon definition of what a data space is. So it might well be a data space in any case, if you want it to be. I think that's fair to say. Maybe also like I think there's time for one more question. Also, when I think about, because I would now think about research settings. I would think about for example, kind of marketing kind of settings. Imagine we would be in a sector where the volume of data is much larger than that, maybe even. How, like, is there any how can I expect the kind of performance to look when I have like gigantic data sets? Imagine, I don't know if we could.
That's a good question.
Relevant for kind of geo data, but I don't know if it is.
And I mean, that's a good question. That's actually one of the advantages of confidential computing, because it's based on hardware. You can scale and have more machines. So, I mean, we've done some benchmark. What you notice is a degradation around 15 to 20% of the performance, which is the same order of magnitude compared to other privacy enhancing technologies where it's 10 times or millions of times fold less performant. And also, to conclude, it's a technology that all the processor, the manufacturer are investing in. And for very large data sets, we're talking about genomics, we're talking about IoT data. Next year, NVIDIA is actually coming up with their confidential computing GPU, which will open the doors to even larger workloads inside those data clean rooms. So I think the horizon is looking quite bright in terms of data scaling here.
Well, good to know. Yes, I actually didn't know that. That's interesting. That there seem to be custom chips for these kind of
scenarios. All the chips will become confidential computing ones in the near future.
Oh, very interesting. I think this is going to be an interesting again discussion also in the future to see how privacy enhancing technologies kind of develop. Wonderful, Pierre. I think that's let's call it a wrap. Thank you so much for being with us. I think if people have questions, they can probably reach out to you. Exactly. Again, thank you for being with us, and hope to see you again soon at Bitkom Privacy Conference.
Yeah, and thank you for the invitation again. That was a pleasure.
You're very welcome. All right. There is another. Also, sorry, Pierre. I see there's a question that just came in. If you don't mind.
Please, yeah, of course. Yeah,
okay, sure. Okay, I will just read it out. It says some cloud providers also offer confidential computing setups. What is the benefit of having a separate data clean room provided by Decentriq compared to confidential computing setup with cloud provider?
Yes, so they offer this technology. The main difference is we built all the infrastructure on top to make it easy to use. So still, as of today, using confidential computing is a lot of work, and I think a lot of corporates, even with very large budgets, have tried to use those machines on their own. It's actually a lot of investment. So Decentriq, the past 3 to 4 years, made a first, a fixed, how should I say, upfront investment to make this easy so that you don't need to know the intricacies of this technology to use it. And we also build on top. So we don't have to talk about the whole package, but inside a clean room, you don't not only have the confidential computing part, you have all the little elements that guarantees privacy end-to-end. So synthetic data, differential privacy. It's a full package we offer with Decentriq. It's not just the hardware, the confidential computing part.
Cool. All right. I think this was well answered there. Thank you. Yes, Pierre, thank you so much. All right. I think that's it. Wonderful. We'll close this stage for now. Feel free to take a break. We'll resume the program on the main stage at 5 p.m. So you're very free and welcome to join there again. Enjoy the rest of the conference and thank you.